Hi guys, today should be Wednesday, January 2nd, and the aim is what is the fundamental theorem of calculus? So I'll give you a minute to copy down the aim. So I just want you to know there are a lot of applications of this. I mean, this is probably the biggest part of the entire class, but I'm just going to be teaching you what you need to know in order to answer questions about this on the final exam, and then in the future we'll go into this more thoroughly. Okay, and you can pause this at any time, or you can actually watch this at home and go back and do it at your own pace. Okay, so here is the fundamental theorem of calculus. It says if you have an integral from a to b of f of x dx, that equals f of b minus f of a. And this is where f of x, is the antiderivative of f of x. Okay, so copy that. So this is the actual fundamental theorem of calculus. Basically, what this is saying is that, let's just look at this part here. It's supposed to be highlighting it. Okay, so that is the integral going from a to b, and a to b are constants, and you have some function. So if you find the antiderivative of that, then you're going to have little f of x, except that we're going to put in those values in the places where it says a and b. The easiest way for you to understand this is to just see a problem. So here's an example. Okay, now we've done this before, but we've never had those values of 1 and 3. And so 1 and 3 are called lower and upper limits. So we would say that the upper limit equals 3, and the lower limit equals 1. Okay, and something else that's really important for you to know is that the larger number must be on top. And in the future we'll talk about what happens if the larger number is not on the top, but we're just trying to get everything you need for the final right now. Okay, so let's see how we would solve it. So remember, the integral sign just means you want to take the antiderivative of x squared. So that's just going to be x to the 3 over 3. Now normally you would write plus c, but you only write plus c when there are no upper and lower limits. So that is what we were doing in the past when we just had something like this, and we got x to the 3 over 3 plus c. That's called an indefinite integral. And that just basically means it doesn't have the upper and lower limits. I'll give you a minute to copy that. Okay. But what we're doing right now, since we do have upper and lower limits, that is called a definite integral. Okay, and a definite integral does not need c. Okay, so I'm just going to get this out of the way. So instead of writing plus c, what are we going to do? We make this little bar, and then we're going to write from 1 to 3 to remind us that we still have to use the 1 and 3. But we lose that integral sign because the integral sign is telling us to find the antiderivative. And once you find the antiderivative, you would no longer have that. Okay, so what you have to do is you have to take the upper limit, so that's 3, and put it into the antiderivative. So that would give us 3 to the 3 over 3. Then you're going to put the lower limit into the antiderivative, which would be 1 to the 3 over 3. And then you subtract them. So you're going to get 27 over 3, which is 9, minus 1/3, and that will give you 8 2/3, and that would be the answer. Now, what does the 8 2/3 represent? It represents a lot of different things, but for right now, for the final, all you're going to have to do is calculate this. You don't have to explain what it means, so we just want to get through that. Okay, so basically, that's why the fundamental theorem of calculus says to do f of b minus f of a. So the top limit is the b, and the bottom limit is the a. Let's try another one. Okay, so let's say we have an integral from 0 to 2. And let's do, okay, so let's say 2x squared minus 3x plus 1. Okay, so the first thing you're going to do is the antiderivative. So that would be 2x to the 3 over 3 minus 3x to the 2 over 2 plus x as it goes from 0 to 2. And if you could simplify, you would do that before substituting in the values, but there is nothing to simplify. So we're going to have 2 times 2 to the 3rd over 3 minus 3 times 2 squared over 2 plus 2. So that's what happens when you put the upper limit in. And now we're going to subtract the lower limit. But you might notice that when you put 0 into each of those terms, you're going to get 0. So you save yourself a lot of time there. I'm going to erase up here to make some more room. Okay, so now we're going to go from here over to here. So 2 to the 3rd power is 8. 8 times 2 is 16, and you're going to get 16 over 3 minus 2 squared is 4. 4 times 3 is 12. 12 divided by 2 is 6. And then you have plus 2. So we have 16 over 3 minus 4 over 1. Find a common denominator. And you get 4 over 3. And that would be the answer for that one. Okay, so it's pretty simple. And you can also use this for trig functions. So for example, if you had this, okay, you do the exact same thing. The antiderivative of cosine x is negative sine x. I mean, the antiderivative of sine x is negative cosine x. And then it's going to be as it goes from 0 to pi over 2. So then you're going to put the upper limit in first. And then you're going to put the lower limit in. Okay, and a negative negative becomes positive, so we could change that right away. So we have a negative cosine of pi over 2. Produce the unit circle. This is the point 0, 1, sine and cosine. So cosine of pi over 2 is 0. Plus, now we need cosine of 0. Here's 0 right here. That's the point 1, 0, cosine and sine. So cosine of 0 is 1, so 0 plus 1 is 1, and that would be the answer for that one. Let's try a few other problems. Okay, so what if we have a negative number in our limits? It's fine. Okay, so we're just going to get 6x to the 3 over 3 as it goes from negative 1 to 1. But like I said before, you'd want to simplify. But usually these are problems you do by hand. So 3 goes into 6, 2. So you want to use the smallest numbers possible. Look at that. So first we're going to put 1 in there. And then we're going to subtract what happens when we put a negative 1 in there. Okay, so 1 cubed is just 1. 1 times 2 is 2, minus. Negative 1 cubed is a negative 1. A negative 1 times negative 2 is a positive 2. We get 2 plus 2 equals 4. Okay, this can also be used if you have an exponential. So let's say we have this. Okay, so either you could just kind of use common sense and figure out what would be the antiderivative to get e to the 2x, or we could practice our u substitution. And let's say that u equals 2x, therefore du equals 2 dx. But we don't want that 2, so we're going to divide both sides by 2. We'll get 1/2 du equals dx. Okay, so we're going to go back here and rewrite our integral. And we have a dx, we have a dx here. So we're going to take out this dx, and we're going to switch it for a 1/2 du. Put the du here, the 1/2 in front. Okay, so we're left with just this, e to the 2x. But 2x is equal to u, so we're going to have a e to the u. Okay, so I have my 1/2, and I'm just going to use brackets to keep that 1/2 separate from everything. The antiderivative of e to the u is just e to the u, right, because the derivative of e to the u is e to the u, as it goes from 0 to 3. Okay, but remember that 0 to 3 was when everything was in terms of x. So before you can substitute anything back in, you have to change that u back to what it really equals, and that's this over here, 2x. So it's really e to the 2x as it goes from 0 to 3. Okay, I'll make some room up here. Okay, so I'm going from here up to here now. So 1/2, and now I'm going to put the upper limit of 3 in there. So I'm going to get e to the 2 times 3 minus e to the 2 times 0. Sorry about that. Okay, so I get 1/2 e to the 6 minus e to the 0. But anything to the 0 power is 1. So this would be your answer. Okay, and let's do one more and then we'll stop there. Okay, how about this one? Okay, so we need the antiderivative of 2 over x. Now, this is the one you cannot say that this is equal to, don't copy this, 2x to the negative 1. We don't want to do this because if I do the antiderivative of that, I'm going to get 2x to the 0 over 0, and we know we can't do that. So this is going to be turned into a ln situation. But what we could do to make our life a little easier is we could pull out the 2, because 2 is just a constant, so we're allowed to pull that out. We had a rule about that. And now we should know that the antiderivative of 1 over x is just ln x. I can easily check that because the derivative of ln x is 1 over x as it goes from 3 to 4. Okay, and now I can just substitute in, so I'm going to get ln of 4 minus ln of 3. And you might or might not remember that there was a rule that had like log of a over b is equal to log a minus log b. So if you wanted to, or if it was multiple choice and nothing matched, you could do 2 times ln of 4 over 3. These two things are exactly the same. So this or this would both be the correct answer. So what I would recommend you do is check in your online or YouTube or in the review book and look for definite integrals. So that's what you're going to look for. So let's just summarize for a moment. So these are called definite integrals. If you want to look online for more information, that will be the topic. And remember, the larger number is always on top. And you're going to find the antiderivative. I'm going to just use AD for antiderivative. Then substitute the upper limit and subtract from it the lower limit. Okay, so not terribly difficult, sometimes a little tedious. Yeah, but that's pretty much it. Okay. Any questions? You can ask me about it next week, and you can expect to find a definite integral problem on the final exam.